All right, 1.5 is analyzing graphs of functions. So in section 1.4, you studied functions from an algebraic point of view. In this section, you will study functions from a graphical perspective. First example, graph f of x equals negative 3x plus 7. Can anyone tell me what type of function you think that is? If you had
Linear.
to
Linear.
linear. That's nice. Someone knew it was linear. If you knew it was linear, great. How do you know it's linear?
The exponent if it's not 2 or above.
Exactly. Okay. So what is the highest exponent for this one?
1.
1. So whenever your highest exponent is 1, you have a linear function, and your graph will look like a, I know I'm asking real trivial questions, but
A
your
line.
graph will look like
A
a
line.
line because it's linear. It's a line. Okay, good. It's best to know before you graph something how it's supposed to look beforehand. That might help you out because you don't want to end up in a situation where you think it's you graphing a line and it actually curves. So
So
you
Miss
need to.
Thomas.
Mm-hmm.
Okay, so I ain't never been really math ain't never been my strong subject. So when you say like you're gonna do a graph and you supposed to know like how can I tell right now just by the negative 3x plus 7 how it's going to look?
Because that x to the is to the first power. So
Mm.
because the x is to the first power is going to be a line. If it was to the second power, can y'all tell me what that's supposed to look like?
Parabola.
Parabola, which is in layman's terms looks like a what if you had to break it down to somebody?
A U.
A U. A U. Very good. And we're gonna learn this in this class. I think that was Bear. We're gonna learn it. So
Yes.
you're gonna learn it. You're gonna learn this. They just happen to know it already, but I'm gonna basically teach you that over.
Okay.
So don't worry. All right. Now, if I say graph something, what do y'all normally do? If your instructor says graph this equation or graph this whatever, how did y'all do it? How did y'all graph? Coordinates. Nice. You gotta find some coordinates. I like T tables, and I'm gonna draw a T table today. It's gonna be sort of kind of like on steroids, but it's a T table. All right. Normally you have an X here, right? And then let's see. What's normally over here?
Why?
Yep, normal Y. But since we're dealing with functions, what do y'all think we're gonna put over there now? F of X, F of X. Yep. But I'm gonna be extra. I'm always extra, y'all. So I'm gonna go ahead and put all of it. F of X equals negative 3x plus 7. And I'm gonna draw another line. We're gonna take our time graphing today. And then that wasn't straight. Let's see. Do a better job here. And then I'm going to say what is f of x, and then we're going to write out the point like so. All right, what numbers you want to plug into x? Any number you want to plug in?
0, 1, 2, 3, 4.
Okay. Okay, okay, I agree with zero. Zero is nice, and one, I like one. I like to put in a negative number, a positive number. I want to know what's going on the left side of the y-axis, what's going on in the middle, what's going on the positive side of the y-axis. So what's probably the easiest negative number we can plug in?
-1.
Yeah, let's try -1, and we'll do 2. But technically, since we already know it's just a line, technically, how many points we need to draw a line? Really?
2.
2. We only really need 2. But I'm just, doing some extra ones just to make sure we got it. Okay. It's a good idea to do 3, because you just want to check the other two. But technically, you only really need 2 for a straight line. Now, you really need to do more than that when your graph is not a straight line, like when it's a parabola, when it's cubic, when it's a absolute value. You're going to learn all of that later. All right, let's plug in -1. We're saying when x is -1, what is f of -1? So we're just evaluating. Notice we're just evaluating the function, really. So we're plugging in -1. What do we get when we plug in -1?
10.
10. So f of x, or f of -1, is 10. And if we had to write it as a point, we're going to write it with parentheses over here. What is it as a point?
-110.
-110 is correct. And I'm just going to say this. The only reason why I put brackets here is because I had already a parenthesis here. So you start with parentheses, you go out to brackets, and what's out the brackets? Anybody remember order operations? You start with parentheses. If you already have a parenthesis, you go to a bracket. When you have a bracket, you go to what? Braces. Might have forgot that, but braces. The little squiggly line. All right, let's move on to f of 0. Plug in 0 for x. You get -3 times 0 plus 7. So what does f of 0 equal?
7.
Very nice. What's the corresponding point?
0, 7.
Very nice. 0, 7. All right. Plug in a 1. You get -3 times 1 plus 7. What is f of 1 equal to?
4.
4. All right. Someone other than Christina, what is the corresponding point?
1, 4.
1, 4. All right. Plug in a 2 next. F of 2 equals -3 times 2 plus 7 is, what is f of 2?
With 3. Is it not?
It's
What is it?
1.
Is 1?
Is it 1?
All right, because -3 times 2 is -6 plus 7.
Plus 7.
1 and the corresponding point?
2, 1.
2, 1. So we're going to plot these points. I'm going to change colors over here. All right. Let's plot the first one. -1, 10. If I'm at the origin, where's the origin, everyone?
In the very middle.
In the very middle,
0.
which corresponds to a point of what?
0, 0.
0, 0. If I'm at the origin, where would I go to plot -1, 10?
To the left.
To the left, how many units?
1.
1, and then
Up 10.
up 10. Very nice. -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Way up here somewhere. I'm going to identify what that point is. -1, 10 here. All right, what about 0, 7? I'm at the origin. Where should I go?
Up 7.
Up 7.
Very nice. 1, 2, 3, 4, 5, 6, 7. All right, just to say it again, you really see, you could draw a line with those two, but you really want an additional point to check those 2 points, to be honest. All right, and then 1, 4. I'm at the origin. Where are we going for 1, 4?
Go to the right and up 4.
Correct. Right 1, 1, 2, 3, 4. And it's looking like we're doing pretty good because that looks like it's in the same direction. All right. And then 2, 1, I'm going to go ahead and do this right here. Then we always, if possible, use a straight edge. Anything that has a straight edge to it, could be your student ID card. I don't care what it is. I'm pretty sure y'all don't have rulers at the house. But whatever you can do to draw a straight line on your piece of paper. Then I'm going to put arrows on the end. Why am I putting arrows on the end of my line?
Because they don't
Because
stop.
it continues.
Stay
It
ongoing.
continues. Very good. It's going on to infinity, forever and ever and ever and ever. Now let me say this: in WebAssign or in your textbook, they don't put arrows on the end, but what they'll do is they'll continue this line off the graph, and you can see it like going off the graph, right? You'll see it going off the graph. That means that it's continuing forever. Okay, that means it's continuing forever. All right, let's see. There you go. All right, so if it's going off the graph on WebAssign, that means it's continuing. Just a tip. All right, using the graph below, determine if you can figure out the reasoning behind the solutions to the function notation. Can you figure out what does alpha negative 2 equals 4, alpha 0 equals 3, alpha negative 1 equals 3.5, and alpha 2 equals negative 1 have to do with this graph over here? I want you to take a look at it.
Those are the y coordinates.
What are the y coordinates? What numbers? Give me an example of what is the y.
3.
Okay, you're talking about this 3 right here? What are you
Yes.
saying?
Yes, I think.
Okay. All right, anybody else can help?
By the looks of the graph, it looked like 4, 3, negative 1, and 3.5 are all the y's, and negative 2,
Okay.
negative 1, 0, and 2 are the x's.
Very nice. This is basically corresponding to the points. We just kind of went over that. All right. This is x. We always know that's the input value. And we know that f of x equals y, right? So we know that this is the y. All right. F of x is the same thing as y. So anytime you have f of something equals something, that's your y. So when you look on the graph, you can see that negative 2, 4, this is like saying negative 2, 4 is on the graph. Negative 2, 4 is right here. Or f of 0 equals 3 corresponds to a point of 0, 3 on the graph, right here. F of negative 1 equals 3.5 corresponds to negative 1, 3.5 on the graph. Negative 1, 3.5 right in here. And f of 2 equals negative 1 corresponds to the point 2, negative 1 on the graph. 2, negative 1 is right here. All right. Do we get it? All right.
Yes.
Give me put the number 2 in the chat if you understand what the correlation between that graph and that function notation. All right. Okay. I'm feeling good about that. We're going to do a couple examples like that, and then we're going to stop. Now look at the following graph of a function f. We do not know what the function is. However, we are still able to evaluate the function by using the graph. So we're doing what we did last week. We are evaluating a function. But this time, they didn't give you the actual function. They gave you the graph of the function. And we are to evaluate the following. Let's look at the first one, f of 4. For this one, what is the x value? F of 4. What is the x value?
It's 4.
4.
4. Yep, x equals 4. So it's telling us what it's asking us to figure out when x equals 4, what is y? So let me erase this. So when x equals 4, on the graph, when x equals 4, what is the corresponding y?
Is it 0?
Very nice. Where's the corresponding y? Okay, because this is 4 right here. This is x equals 4, and the graph, the point on the graph is 4, 0. So the answer is 0 for this one. All right, let's go to the next one. Alpha 1. What is x in this situation?
1.
1. And it's telling us when x equals 1, they want us to find or evaluate this function when x equals 1. What is y when x
2.
equals 1?
It's 2.
2. All right, that's nice because that's the point 1, 2. Y'all get it?
Yes.
Yeah.
All right, alpha 3. What is x in this case?
3.
3. X is 3 because it's the input value inside the parentheses. What is the corresponding y?
Negative 2.
Negative 2, because this is the point right here, 3, and you kind of like making an intersection, I guess you would say. When x equals 3, y, this is the y-axis, is negative 2. So 3, negative 2. All right. What I want you to do for this one, I want you to guess at what you think. Not really guess, because some of you, I can tell, you know how to do it now. But if you're struggling a little bit, just write down what you think g of 0 equals. Let's say this function is called g of x. What do you think g of 0 equals, g of 1 equals, and g of 4 equals? And I give you 60 seconds to do that. And then we'll discuss the answer, and then we'll transition for today. All right? All right, we'll transition to the quiz. All right, 60 seconds. Let's look at the graph and write down some of your answers. All right, g of 0, what do you think?
0.
0. Nice. This is 0, 0 right there. 0, 0. All right, g of 1.
3.
3. Very nice. Actually, they told us what that point was is 1, 3. But even if they didn't tell you it was 1, 3, you look at 1, which is right here. You go up and make an intersection to the y-axis. That's your 3 right there. And g of 4 equals
0.
0 again, because it went right back down. That is 4, 0. How are we feeling about evaluating a function given the graph? Good. How do we feel about it? Good?
Good.
It's not as bad as it looks.
It's really not. That's how math is in general, to be honest with you. Once you understand it, you know, once it's explained, you get it, it's like, oh, that's easy. But once you, if you didn't understand it, it's hard. That's how it works in math. You get it, oh, that's easy. And when you don't get it, it's hard. But once you get it, you're like, oh my God, that was so easy. I don't know what took me so long.